Welcome to Unit 4, Lesson 17, Completing the Square and Complex Solutions. So let's find complex solutions to quadratic equations by completing the square. And you probably did this in Algebra 1 last year. Okay, so what do we mean by completing the square? If you take a traditional quadratic formula, ax squared plus bx plus c, and we divide the middle term by 2, the b term by 2, and square it. You add it to both sides, and you'll get something like this. And we're going to practice this today. So here's an example of completing the square. Take the b term, divide it by 2. So we would do negative 18. We would divide it by 2. We would get negative 9. We would square that. And that's where we get positive 81. Add 81 to both sides of the equation, and then on the left side, you will see that this is a perfect square. Take the square root of 81, which is 9. This becomes your term inside the parentheses over here. And then you solve from here, and you finish. So this is what we're going to practice today. All right, now, up until now, we've been able to solve equations. So let's look at 1. 1 is a difference of squares. So this is x plus 5, x minus 5. So 1 goes with this one. And the roots are positive 5 and negative 5. Okay. X squared minus 5 is a difference of squares again, but this is x plus root 5 and x minus root 5. So 2 goes with this one, and our roots are this. Now, 3. If I subtract 25 from both sides, I get x squared equals negative 25. When I take the square root of a negative number, it's not real, it's imaginary. So the square root of 25 is 5. The square root of negative 1 is I. So x is plus 5i and minus 5i. I should probably put a plus in there. So the top one goes with this one, and that goes down here. Okay, so let's solve these problems. So when I take the square root of both sides, I get x minus 5 equals 0. I add 5 to both sides, and x will equal 5. Okay, so for the next one, I do the same thing. I take the square root of both sides. To get rid of a square, take the square root. I get x minus 5 is equal to positive 1, and I get x minus 5 is equal to negative 1. Remember, when you take the square root of a positive number, you get 2 roots, one positive, one negative. The reason why we didn't get anything with 0 is not positive, nor is it negative. And so you see me added 5 to both sides, x equals 6, x equals 4. And then for the last one, take the square root. And now we know when you take an even root of a negative number, it's not a real number. So you get x minus 5 is equal to I, positive and negative. X minus 5 is equal to negative I. So you get x, well, I got to add 5 to both sides, just like the previous ones. I get x is equal to 5 plus I. And I get x is equal to 5 minus I. And that is the solution. Okay, now we're going to actually complete the square. So this is the way I like to do it. What we have to do is make a perfect square. I have my x squared and my ax squared and my bx term. I only need these terms. I'm going to take my b term. So a is 1, B is -8. Remember, the sign in front of the term goes with the term. And C is +13. So what I'm going to do is take my -8. I'm going to divide it by 2. I get -4. And when I square it, I get 16. This is the number that I'm going to add on both sides. So watch what I do. I'm going to move the 13 over. I'm sorry. Plus 16. I'm going to move the 13 over. Equals 0. So since I added the 16 on the left, I have to add it on the right. So this is the new number I added in. Now, B divided by 2 squared is -4, is 16. So I'm going to do x minus 4 quantity squared plus 13 equals 16. So now I'm going to subtract the 13 from both sides. So I get x minus 4 quantity squared equal to a number. And now this just looks like the one from the previous page. So all I got to do is take the square root. I get x minus 4 is equal to the root of 3. And I get x minus 4 is equal to negative the root of 3. Add 4 on both sides. X is equal to 4 plus root 3. And x is equal to 4 minus root 3. Okay, now let's look at the same problem with a different number for our b. So I take my b term, which is -8. I divide it by 2. I get -4. Then I square it. And why do I do all of this? Because 19 is not easily factorable. The only factors of 19 are 1 and 19. They add to 20 and they subtract to make 18. So we have to do this because this is not easily factorable. So when I add this in, plus 16 plus 19 is equal to 0 plus 16. I added this 16 on the left. I have to add 16 on the right. So I get x minus 4 quantity squared plus 19 is equal to 16. So you're saying, Mr. Walls, where did the 16 go? This is a perfect square trinomial, which we looked at in a previous lesson. That goes there. That all gets condensed down into that term. So we subtract 19 from both sides, and we get x minus 4 quantity squared is equal to -3. 16 minus 19 is -3. Now, when I take the root of both sides, I have a negative number. And from the last lesson, I showed you that -3 is -1 times 3. X minus 4 is equal to I root 3, positive and negative. So let me do this over here on this side. You get x minus 4 is equal to I root 3. And then x minus 4 is equal to negative I root 3. So add 4 to both sides. Add 4 to both sides of the equation. X is equal to 4 plus I root 3. X is equal to 4 minus I root 3. And these are your answers. Now, here's the same problem again. And we already know the solutions here. So basically, if you were to graph these, what would it look like? Okay, so if I remember, this was 4 plus root 3 and 4 minus root 3. So from the previous page, x, sorry about that. X was equal to 4 plus root 3 and then 4 minus root 3. So what does that mean? If we were to graph this, and I graphed it on the calculator, So this point right here, where it crosses x, is 4 plus root 3. Root 3 is about 1.7. So that's about 5.7. 4 minus 1.7 is about 2.3 or something like that. So this is 4 minus root 3 over here on the left. And this is what our parabola looks like. It crosses the x-axis twice. When you get two real solutions, that means it crosses the x-axis twice. Now, since b is just x minus 4 quantity squared, so you get x is equal to 4, and that's it. What does that mean graphically? That means that it touches at 4, and this is what your parabola looks like. It just comes down, touches the x-axis at 4. This is what this means graphically. And then minus 8x plus 19 looks like, it looks like this orange graph. So when we say no real solutions, this quadratic graph, this parabola, never touches the x-axis. And that's why we say it has no real solutions. It never touches x anywhere. So no real solutions. That's what no real solutions mean. So no real. And we saw that in the previous example. So this is 4 plus I root 3 and 4 minus I root 3. This had one real solution. That means it touches the graph once. And this had two real solutions, which means it touches the x-axis twice.